Welcome, lovely viewers. Thank you for joining us again for another edition of Talk on STEM Careers. My name is John Paul Osabute, and I'll be your host for today's program. We are Teen Leadership and Entrepreneurial Development Foundation, and we seek to provide leadership coaching and mentorship to younger adults, especially in the rural areas. We are trying to enlighten them on STEM careers and also encourage them that it is possible for them to achieve a career in STEM. Today, we are privileged to be joined by a structural and a civil engineer. His name is Dr. Godwin Atta. Doctor, you are welcome to our program.
Yeah, thank you. Thanks for having me.
All right. Okay, so without much ado, Doctor, can we please know who is Dr. Godwin Atta?
Yeah, I'm Godwin Atta, just like you said. I was born and raised at the Inase in the western region of Ghana. That's the Nzema area. I had my basic education at the Holy Child Preparatory and GSS in Inase and completed in 1996. So that's a long time ago. From there, I went to Ghana Secondary Technical School. So I'm a giant for my secondary school.
That's interesting.
So, yeah. So from there,
I wasn't a giant.
Oh, you were a giant too. Yeah, that's good.
Yeah.
Yeah. So from there, I went to Kwame Nkrumah University of Science and Technology, and I pursued a 4-year Bachelor of Science degree in Civil Engineering, which I completed in 2005. So that's 15 years.
Wow.
Yeah, that's a long time. Yeah. So after my university studies, I stayed on as a teaching assistant for a year, working at my department, and I was the TA for a structural engineering professor at the time. So that was how come I ended up in structural engineering. I moved to the US for my master's and PhD at the University of Akron, and currently I'm working as a structural bridge engineer for Lockwood Andrews and Newnham Inc. It's a full service engineering company. I'm married with 3 kids, Ivan, Jeffrey, and Raina.
Interesting. Okay, thank you, Doctor. Viewers out there, if you are live with us on Facebook, please kindly follow us at Teen-Led Foundation. Also, please like our page on YouTube and also on Facebook. If you have any questions to ask, please drop them in the comment section on Facebook. And if you are live with us here on Zoom, please, you can give us a wave and we will call you up to ask your question. Doc, you said you grew up in Inase, and I think that is a rural area in Zima. How was life like growing up as a child in a rural area?
Yeah, and Inase might qualify as a town now. Right now, to Ghana standards, it's a town. Okay. It was quite interesting, but when we were there, things were slightly different from what the situation is now. I remember as back at 96, we had no electricity, so I had to ride my BC steady with lanterns. Inase is a marketing community, so the usual after school running to the market, playing soccer after school, and all that. My childhood was quite interesting. it was fun. I basically did whatever every typical child do. And UNASI in itself had some bright spots. During road construction from Apimenim to Elugo, it was an international highway connecting Ghana towards Cote d'Ivoire. The construction company that was working on the project, they had their headquarters in Enyinase. So because of that, kids growing up in Enyinase at least had a first-hand idea about what people generally in the workplace do. So we had a lot of people coming there. There were engineers, there were operators, all kinds of careers that had to do with road construction. So that's how it started over there. Also, Inasi also happened to be the operations headquarters of GMPC at the time. So when the construction company left, they had set up a camp. That part they had electricity and everything. And then when they left, GMPC operations came, and then they came to take over. So growing up in Inasi, at least I had seen how life be in some of those careers is going to be, because you could clearly tell the kind of life those working for those companies led was quite different from how the ordinary person also lived in Inasi. So there was enough motivation as a kid seeing all these people come through with and trying to learn something.
Okay, that's very interesting to hear. Doc, so if I'm right, you took your inspiration from the road constructors out there while schooling in Inasi. You saw them and you wanted to be like them.
Yeah, so basically my career was influenced by the environment that I found myself in. And fortunately enough, my dad worked for that company as a materials tech lead. So my dad led the lab for the soil materials and everything. So growing up, I basically was influenced by the type of environment at the time. Yes, so I can say that's where my whole idea about structure, about civil engineering started.
Okay, Doc. So in the university, would you say that your class was either male dominated or female dominated? And how did this actually influence your life in school?
With similar to most engineering classes, I don't think it has changed that much. It was male dominated. I think the ratio was like 4-1. But the good thing is, civil, we had more females than any other engineering discipline that you could talk about. So I think we had about 30, 35 ladies in our class. And that was a lot for an engineering class. Yeah. But there were over 120 men. So definitely it was male dominated.
Okay, so what were some of the challenges you were facing in school, and how did you overcome them?
General challenges in the university had to do with how lectures were delivered, and like our whole system of how information was impacted to us was very different. Good for me, I've been able to have the best of both worlds. I've schooled in Ghana, and I've gotten the chance to also school over here. And I can say the difference was that much, and I could explain why maybe we were kind of struggling a little bit in Ghana than over here. Because back in Ghana, our class, we had a very high number of students, so that personal interaction of the student-lecturer relationship was actually not there. So if, let's say, after a lecture, you couldn't even get something, you cannot just walk to the lecturer's office and tell him, hey, say, can you just help me with this, or can you go over this session? We didn't have that over there. So that was one of the challenges. And due to the high class sizes, it wasn't easy for lecturers to actually give us assignments. And you find out that the best mode of learning is if, let's say, after every lecture, you have an assignment to get a chance to go over the material a little bit more. So we had to wait all the way till when there was the mid semester or like a final before everyone would really get on their books and try to, ace the exam or something like that. I think those are the challenges that we had. High class numbers making instruction not very effective.
Okay, Doc, I believe this ratio affected students' life and also academics. Looking back, what would you have done differently amidst all these challenges?
I think due to the nature of that, my life was more centered about studying the whole time. I wish I could have introduced a little bit more of extracurricular stuff to what I did at the university. I would say my time at the university was boring. I was always studying. So if I have to be at the university now, I will still study, but maybe I might add a little bit, try to be involved more in the community, try to have the best of everything over there. That's what I might have done different.
Okay. Obviously, you are well established now because of your hard work in school. What was your study techniques?
Study technique at the time, I had to just pass my exam. So the same formula that the typical Ghanaian student will use, go over the notes, trying to cram what you think you can cram, trying to remember, memorize, and try to understand those ones that you understand, and try to make sure you are passing the exam. I think that was what I did. But along the years, I've realized that's not the best way to learn, because we are not just learning to pass exams. We are learning to understand what we are doing so we can use it in our daily lives. We can impact society with that. So I think if I have to advise somebody now, the approach will be try to understand whatever that you are taught in school. Even if the lecturer left and you didn't get a concept, by the power of technology right now, conditions now allow you to be able to access all kinds of information everywhere around the world. You can even have access to notes from different parts of the world. You can actually listen to lectures from different parts of the world online. So the current approach should be students should try to understand whatever that they are learning in class, and not just to pass the exam.
Okay, students should try and understand whatever they are learning. You shouldn't always be cramming everything. Thank you, Doctor. I believe that you really loved studying a lot, and with all what you studied throughout your university life, which part of your studies did you really love best? The subjects.
In the university, funny enough, when I was in KU University, looking at the specializations, I had done a little bit more in water supply resources in school, because I can boldly say at the time our structural engineering instruction was not the best. Some of the lecturers we had were terrible, the truth be told. So I loved structural engineering, but I think in school, most of the projects that I would find myself doing were in water supply. I remember my final year project, I had to develop a software for managing managing small town water supply systems. And along the line, I had done a whole lot of other water stuff. So in school, I liked structural, but it looked like I was a little bit more aligned to the water side.
Okay, that's interesting to hear. In your introduction, you made us understand that as a kid, living in the Inase, you took your inspiration from your dad, who was part of the team of the contractors who were building the road from Apimenim to Ivory Coast. Would you say that having mentors or role models is very important and key to achieving a career in STEM?
Yeah, it is. It is very important. I'm going to use my current profession as an example. In structural engineering or in engineering in general, if you want to get licensed, I'm going to use the USA. I know in Ghana it's a similar system. Before you are allowed to even sit for the licensing exam, you need to have worked under a licensed engineer for a number of years. So that alone, the profession indirectly encourages some kind of mentoring and learning. So mentoring, I would say, is very, very important, both directly.
Yeah. Okay. Lovely viewers out there. If you just joined us on Facebook, please like our page. If you have any question, please drop it in the comment section, and we'll read it out to Dr. Atta to answer them. Please, you can also like our channel and subscribe to it on YouTube at Teen-Led Foundation. If you are live here on Zoom with us, you can wave us or give us a wave, and we will call you in to ask your questions. Doctor, please, we are now going to zoom into your profession. We want to know that have you ever had any other profession apart from being a civil or structural engineer?
Yeah, I've done some kind of teaching, not as a professional, but at the various stages of my life, I really been a teacher. After secondary school, after GSTS, I went back to Holy Child Preparatory to teach there for 2 years. And when I graduated from KNUST, whilst waiting to start national service, I volunteered to teach at a secondary school at the Wearable, Bokas, Senior Secondary, as a science teacher. I think I was there for 3-4 months. And I became a teaching assistant. So definitely I was teaching at KNUST. And whilst doing that job, I had a side job as a science teacher for a private secondary school in Kumasi. Yeah, so unofficially, I can say I've done a lot of teaching, and I might move in that direction later on. I'm not sure, but I love to teach.
Oh, okay. That's good. Doctor, how has your career path been like so far, looking back?
I started off in Ghana from KNUST. I started working for a civil engineering company in Kumasi called Compro Limited as a civil structural engineer. We happened to work on a number of university buildings. The most predominant is the University of Education, the Kumasi campus. Most of the campus buildings over there, we worked on the buildings at the time. I worked on some other buildings at the UDS in Wa, so I got the chance to travel to Wa. I did a little bit of the affordable housing project at the time in Tamale during the planning stages, so I got a chance to also get to Tamale. And worked on a number of hostels and all that. So in Ghana, I worked as a structural engineer, but I did a little bit more of the buildings aspect of that. Currently, what I'm doing is I'm still working as a structural engineer, but I'm doing a lot more of the bridges aspect of structural engineering. So I've been able to have the best of both sides in buildings and in bridges, and that's where I'm at right
now. You have obviously had a very interesting career path, and I believe our viewers out there now are wondering who a structural or civil engineer is. So, Doctor, can you please help us just demystify these thoughts right now?
Yeah, so the work of a civil engineer is something that everybody gets to see every day in your daily life. The house that you might be staying in might have been, there were things in there that might have been done by a civil engineer. Civil engineering is the broad field, and structural engineering is the specialization. So first, I'm going to talk a little bit more about civil engineering. When I finish talking about that, then I'll narrow down to my specialization in civil engineering, which is structural engineering. I'm going to show this short video to let people know what civil engineers do, what our job entails, and all that. So bear with me. Let me share this video.
Okay.
Are you a problem solver? Do you want to work with the latest technologies? Do you want to make the world a cleaner and safer place? If the answer is yes, a career in civil engineering might interest you. It's amazing how much of the world around us has been shaped by civil engineers. Civil engineers build skyscrapers, tunnels, stadiums, and everything in between. They are responsible for our roadways, airports, and bridges. They maintain our lakes, rivers, and parks. They are dedicated to creating a more sustainable world. Their work influences where people work, live, and play. They design the road, rail, and air systems that get products from farm to table and keep everything on the move. They plan cities and deliver drinkable water. These are just a few of the achievements of civil engineering. Think about helping design a transportation system that doesn't need drivers. Or developing a solar purification system so people living in third world conditions have drinkable water. Civil engineers have limitless potential to explore and grow with the changing world. There are many different types of civil engineers. Do you want to ensure others are safe on their commute to work? Do you want to design and build the structures that support industries around the world? Do you want everyone to have access to clean water? While civil engineers have a foundation in math and science, they also use their creativity and ingenuity. You can choose to specialize in an area of civil engineering that best suits you. We often don't realize the many ways civil engineers improve our daily lives, above ground and below. Civil engineers have made major advancements, and the most exciting breakthroughs are yet to come. The possibilities are endless because civil engineers are transforming yesterday's problems into today's solutions. Are you ready to make a difference? If you want to change the world, civil engineering may be the career for you. Visit this website or search online for more information about civil engineering.
Okay, that was an interesting one. That was on civil engineering. So we are going to now take a look.
Yeah, let me talk a little bit about what you watched on the video. So civil engineers generally, we plan, design, construct, and maintain the built environment. The built environment is basically wherever you live. So we're concerned with buildings, your water supply, the way your waste is managed, the transportation systems, bridges, like most of the things that you deal with in your daily life, a civil engineer at least might touch a little bit of that. So in a nutshell, we say we make the world habitable. So that's what civil engineers do. We make the world habitable.
Okay, we make the world habitable, civil engineers.
So with civil engineering, we have specializations. One thing about civil is it's one of the oldest engineering professions. There used to be two different types of engineering. It used to be either the military engineering or civil engineering. So along the line, as other fields developed, they all moved to be standalone on themselves. So currently, when we talk about civil engineering, we are talking about specializations in transportation engineering, geotechnical engineering, water resources engineering, structural engineering, and sometimes environmental engineering. So these, and you can add the construction engineering part to all of this, since construction happens everywhere. Whatever civil engineering does, the end product should be some kind of construction or something tangible that you can see. So that's what civil engineers generally do.
Thank you very much, Doctor. I believe growing up, while you saw those contractors on the road, there are a couple of engineers over there too. And even as you said right now, apart from civil engineering, there are other branches of engineering. I would like to ask, why did you choose civil engineering in particular? Why not any other profession but civil engineering?
Yeah, so first I was biased. I wanted to get into an area where my dad worked, so that's one. And the second thing had to do with the job opportunities where I found myself at the time. That's in Ghana. In Ghana, I think it was a lot more, it was a lot easier at the time to find work as a civil engineer than some of the others. I don't know the situation now, but it looked like almost every graduate out of our class would, at least at the point, find something to do. Since we are a developing country, we have a lot to do in that area. There is always some form of construction going on. So my career choice was also informed by prospects for work. And basically, my financial, I liked chemical engineering too, but initially that was what I had thought about doing. But looking at the job prospects in Ghana at the time, I had to think about civil. So that's how come I ended in civil. And it was the course I had chose as my first, second, and third choice whilst entering the university. I was sure that was what I wanted to do.
Okay, thank you, Prof. Doctor, do you ever intend on changing profession? And why would that reason be?
Currently, I'm not looking at leaving civil engineering. I might be in civil either in practice or in academia. So if maybe I have to divert a little bit, I might be teaching the next generation of civil engineers. I might just want to get into the management aspect of the profession over time. So that's what maybe I might do. Try to get into management, but it is still going to be in engineering.
I believe it's all these years of experience in the job, you've had a couple of achievements. We would like to know which has been your greatest achievement so far.
Greatest, I would say I'm still working, so maybe the greatest is yet to come. But so far, I would say there was one project that I had done here in Austin, Texas. It was a diverging diamond interchange where we applied accelerated bridge construction processes. So the traditional construction starts from ground up, but on that particular project, we have to start from up down. So what happened was, yeah, it was like we were building we were putting up the whole bridge on the soil.
Mm-hmm.
Then after the bridging was up, then we had to excavate under it to get
Wow.
that
Okay.
side working. So I was part of the team that did that. I had to design some assessments of it. I don't want to be technical, but I think that was a very interesting project. But apart from that, I've worked on a lot of other stuff.
I can imagine you've been doing a great job out there. So I believe you have many plans for the future. So what's your target for the next 5 or 10 years to come?
5 years, I want to get a little bit more towards the project
Oh,
management aspect of structural engineering. Funny enough, I forgot to talk about structural engineering. What I had shown was civil engineering. So
yeah,
I can just go back briefly and talk about structural engineering a little
yeah,
bit.
of course,
So
of course.
with structural engineering, we design all the structures. If you say a structure, we'll try to come down to the level where people get me. Let's say if you have a building that supports a certain type of load, anything that will support a certain type of load, we can refer to as a structure. So structural engineers, basically, we deal with the design, the planning, design analysis of buildings, bridges, and other infrastructural projects, uh, and every section of it which carries load. So that actually overlaps with a number of professions. So as a structural engineer, you can find yourself working in a civil engineering company where you are working on bridges, or you can end up working for an aerospace company as an aerospace structural engineer. We have structural engineers in the offshore industry. We have structural engineers working on ships called marine coastal engineering. So we have structural engineers in various fields of engineering. But what I've been doing predominantly is structural in civil. It's structural in civil. So basically, we do the design of buildings, bridges, um, make sure they are safe for the public so that they will avoid collapse. So sometimes people confuse a structural engineer with an architect. Let me clear this. Most times, the architect will come out with an idea, and the engineer will bring the realization of the architect's idea into fruition. So an architect can come out with something, but you will have to make sure what the architect has come up with can be built. So if an architect design a stadium, it will look so nice, everything, the concept, everything. But the question now becomes, can that idea be constructed? Can it be built? So as a structural engineer, what you do is you go in, you look at all the loads that is going to come onto your structure. So let's say a typical story building. Let's say offices. I can just ask you to tell me some of the loads that can you find in offices. One, people will go in there to work. So you definitely know that there should be load from people getting inside the building. The weight of the building itself. The building should be able to support its own weight. That's another thing.
Exactly.
Yes. Another thing that maybe you might not be thinking about is the building should be able to withstand all the external factors like strong winds, like earthquakes, if it was designed for it. So the structural engineer will have to estimate all these and project. And then after you've been able to look at all that, then you're going to select materials that will be able to withstand. You select materials and create shapes and put them together to withstand all these forces. Yeah. So what you do is you're going to specify, let's say, use this type of concrete, in Ghana, we say use iron rods and all that. People might be building, they know, okay, over a lintel, I have to put iron rods in it. But there is a reason why you are doing that. Because as a structural engineer, you should also understand the properties of materials. You should have an idea how strong some of those materials are. You should be able to know how you'll be able to combine materials to gain a certain level of strength. Yeah, so that's what we do. So similar to the lintel in a building, which we call a beam, you are combining iron rods with concrete. And there is a reason for that. The simple reason is that concrete is very strong when you try to crush it. But then when you try to pull it apart, it is very weak. So your iron rods is very strong when you try to pull it apart. So if you can put both of those two materials together, then they can work together to complement each other to actually help you solve that part of your problem. So a structural engineer will tell you, okay, combine concrete, put this number of iron rods in there. So that's the work of a structural engineer, which actually happens in some of these buildings that we see, but we might not have thought about it. So we make use of concrete, steel, wood, this type of material. And it's a very broad field. Like I was saying, we have the building side, we have the bridge side, we have the industrial side. People will move that even into aerospace, into automotive. It's a very broad area. Yeah. But to be a structural engineer, you most times will be a civil engineer first.
Okay.
Yeah. I had a short video. I don't know if time will permit. I could have shown it, but that will just explain. I don't know if time would allow for that one. But I can show them.
Yeah. So, Doc, that's a lot of analysis you put in when working around. There is this idea that engineering is very hectic. And I would like to know, under a normal day, I mean, what's your normal routine for work? When you go to work, what's your normal routine going about doing whatever you do?
Yeah, so basically, because our projects, they span a certain length of time. So a typical day at work, you might go continuing a design that you started, replying emails, replying to RFIs, reviewing your colleagues' work, or sometimes attending site meetings. Now, and depending on the level that you are at, you might attend management meetings and all that. So it's just like the regular day at work for.
Thank you very much, Doc. Now we are going to zoom into the STEM field. We are trying to be a little bit biased here. So to our lovely viewers out there, if you are with us live on Facebook, we'd like you to like our program. And if you have any questions, please put them in the comment section. On Zoom, please give us a wave and we'll call you to ask your question. Please also like our channel on YouTube and subscribe. Thank you. Okay, so Doc, what's your general view on the STEM field? I mean, science, technology, engineering, and mathematics.
Yes, STEM has played a role and continue to play a role in the development of various communities. Through STEM, we are able to create the next generation of innovators. So a country that has foresight will have to place premium on STEM, in the STEM, like in the various STEM fields. because we use STEM to solve most of our world problems. For example, looking at the COVID-19 pandemic, everybody is now waiting for scientists to at least come out with a vaccine. So eventually, STEM doesn't solve just peculiar problems for people, but the human race, our survival depends on it. So that's how important STEM is.
Okay, Doc, thank you. Could you please elaborate more on the opportunities the young ones out there could get from the STEM field, the careers in STEM field, and the challenges they might go through trying to take up a career in the STEM field?
Yeah, opportunities. And so first, anybody in STEM try to solve a problem which is basically going to impact the world in a certain way. So being in STEM, you're going to help solve real world problems. And because we are on Earth, we're still trying to understand some things. So there will always be job opportunities for those in STEM. So that's one, increased job opportunity. And most STEM professions are kind of lucrative. That's another thing to look at it. Apart from that, you're also going to gain critical thinking skills. There are even opportunities because whatever that you're coming with tend to benefit a whole lot. I'm going to use this as an example. If you are trying to, let's say you are in Ghana, and you want to most times go for further studies. Most of the assistantships and scholarships that you might find out, I can say most of it are in the STEM field. So there are countless opportunities. There's still a number of problems to solve. So the STEM field is going to be with us. And the opportunities, the job opportunities, it's never going to run out. The challenges that we have with STEM education in Ghana, it's the theoretical nature of how science, tech, the STEM courses are delivered. Looking at our system, we place premium more on the theoretical side of it instead of making it a little bit more interactive and interesting. So I think that is making some people or most students think, science, maths, some of those things are difficult. I think it has to do with the approach. So some of the challenges, we don't have the necessary teaching and learning materials to be able to adequately teach STEM, to make it encouraging to everyone. That's one. I have an example. I was teaching a class where I was introducing students to engineering. And I realized that anytime we got to the practical aspect, I basically got everybody to take part. But once I had to teach the theory before, then you could clearly see some of the students were not interested. I'm talking about in the US and not in Ghana, because studying here is different. But once let's say, we were using a straw to make a bridge, everybody was happy, everybody wanted to take part. But when I had to talk about the forces and all that, it's like the kids, some of them lost interest in it. But in our system, most of the things that we do, it's not very practical. I think that's a challenge to STEM education in Ghana. We need to work on procuring a lot more teaching and learning material to make it a lot more interesting.
Okay, thank you, Doctor. We have a question for you on Facebook. Nanaya Asari Aponsa is asking if you ever had any regrets in your career choices as it relates to the work opportunities.
No, I don't have any regrets. One, I wanted to be a civil engineer, and that was exactly where I found myself working. And most of the places that I've worked, they've been great. There is that work-life balance, so I wouldn't have any regrets where I'm at.
Okay. Thank you, Doc. Let me ask this question. After which we can play the structural engineering video we suggested later on. There is this misconception going around in our rural communities that engineering is a very, very challenging program to do. And to some of them, they think that after taking a program in engineering in the university, you could get stuck and you never get a job to work on in the future. What's your reaction to that?
Yeah, this is what I have to say. It is clearly a misconception. One, engineering opens the doors to the other professions that are not even STEM. I know over here in the US, and I'm very sure very soon it might even be in Ghana. You can start as an engineer, and when you change your mind, if let's say you woke up one day and decide you want to be a doctor, you can still be a doctor in the US with, with an engineering degree. You can start with an engineering degree and end up
Wow.
being a business person. You can start with an engineering degree and be a lawyer. So
Okay.
engineering in itself opens up the world of opportunity to you. So even if after university you feel like the field that you're in, you are not even getting something in there to do, depending on where you are, then you could always move into other areas. It wouldn't be easy for somebody who did or who read a program in business to move to engineering. But as an engineer, you can easily move into their field, and you can. So it's like it will open up that that world of opportunity to you. When it comes to engineering, it's difficult. Uh, this is what I always say. So far as you are focused, you are persistent, and you put your mind to something, you will be able to do it. If there are people in your community who have done it, then it means you can also do it. Yeah. So to
Yeah.
those people, nothing comes easy. There is no course which is easy in this world.
Mhm.
Nothing comes easy. So if you are able to put in the work, then I don't think it's that hard like how people make it seem. Yeah. I wouldn't say it's easy. You have to work. Yeah. So once you are willing to work, you can get into engineering. And that happens with every other field.
Yeah, you have to work hard and nothing comes off easy. Doctor, for young adults listening to us who are out there in the rural areas, I believe some of them are wondering, what will I do, or what would the requirement be if I want to be a structural or civil engineer like you?
Yeah. So you should love science. You should love science. Then at the secondary level, you should definitely take general science with elective mathematics. So that gives you the foundation to jump into any engineering field. Then from there, you can apply to the university or the technical university, whichever route you want to go, and get your bachelor's degree. As a structural engineer, now most people would employ entry level engineers with a master's degree because it is a specialization. Though some people can just do the basic civil engineering and get on-the-job training and end up being structural engineers. But most jobs will prefer someone. I'm talking about the US situation. The Ghana situation, I think we just started masters in structural engineering like 4 or 5 years ago. So the Ghana situation, it's likely all structural engineers who were structural engineers at the time, at least, they got into the field with a civil engineering degree and ended up learning on the job. But in the US, typically they would prefer you have a master's degree.
Okay, that's interesting. Doug, please, can we play the video on the structural engineering?
Yes, let me share this.
Won't collapse or fall over. You see, a structure must be able to handle how tall buildings can withstand windy days, or why bridges don't collapse when large trucks drive over them. Well, the answer is structural engineering. Structural engineers use physics and math to design and analyze the sturdiness of structures. You know, things like bridges, buildings, concert stages, and even roller coasters. Don't get me wrong. Designing any one of these things can involve multiple types of engineering, but it's structural engineering that's responsible for making sure that that structure won't collapse or fall over. You see, a structure must be able to handle the forces or loads that it's likely to experience. Take a skyscraper, for example. It not only has to support itself, but also all the people and furniture inside the building, and then external factors like wind, snow, or an earthquake. The materials and geometry that make up a structure influence how it may respond to those forces. Different materials have different properties like strength, weight, and flammability that can influence a structure's sturdiness. For example, steel is generally stronger and weighs more than wood, and different geometric shapes work better for different purposes. For example, a square or rectangular base can typically hold more weight than a triangular base. So structural engineers perform calculations to determine the best materials and shapes to use in order to build a sturdy structure. So the next time you find yourself at the top of a roller coaster, you can thank structural engineers for doing their part to make sure it's nice and sturdy.
Yeah.
That was an interesting video right there.
Yeah, so basically that included whatever I had talked about previously. So that's what structural engineers
do. Okay. So to our young viewers out there who would like to venture into structural or civil engineering, what advice do you have for them? You know, growing up, what attitude should you think should be instilled in them so that they can be able to achieve what you have achieved right now?
One, they have to be curious. Curiosity, trying to find out how things work, and that is going to bring their minds right into civil or engineering in general. They will have to be focused. Once you are in school, you're taking science, physics, chemistry, maths, and even biology. You have to make sure you are doing well in those classes. Being focused, taking your studies seriously will definitely get you to the point that you want to be at. Then you have to be detail-oriented, paying particular attention to whatever that you're doing. Because if you want to be a structural engineer, it's the little details that matter. So you have to be a detail-oriented person.
Okay, so saying that, would you recommend any kind of resources around for young adults out there to study or use?
Thank God, the power of technology. There is access to YouTube, a lot of other websites where there are countless materials on structural engineering. Whether you are in school or you're now thinking about being a structural engineer, you can just go to YouTube and search structural engineering. There should be a ton of material that's coming up. If you are a student and you need materials to even help you in your structural engineering classes, when you go to YouTube, let's say you type something called statics, let's say, there is countless material on that. Apart from that, if you visit university websites, various universities around the world, they put their lectures online, which you can also access. So my little point is you shouldn't just be looking at the little corner that you find yourself. If you are taking a class in structural, there's something in there that you don't get, you have to explore the other materials out there. Maybe somebody will be able to explain that concept better.
Of course. We are seeing a rapid increase in the advance of technology. How has technology affected structural or civil engineering so far?
Technology has really helped the work of structural engineers to be able to, we can now analyze structures that would have taken months to analyze can now be done in the matter of days. So technology has positively affected the practice of structural engineering. It helps in the rapid solution of real world problems faster. So technology has been good.
Okay, Doc, I believe technology will continue to evolve, and as the world moves along with it, in the coming 10 to 20 years, what do you think the young ones out there should expect, in the field of STEM?
Yeah, they should leverage the power of technology to their advantage. Like some people always have that notion that technology is going to maybe rate humans of the kind of work that we do. I don't think that is going to happen because you need humans to actually program whatever. So you definitely need a human being. Computers, let's say in itself, they cannot think for themselves. Yeah, even in all these new areas that are coming in, machine learning and all that, there is still somebody who will have to put in something and then the computer or whatever, the software should follow. So leveraging the power of technology, using it to our advantage, making ourselves better, learning from all the things that are coming, seeing the positives in it, and making sure we are not using it to actually destroy ourselves.
Okay, that's interesting. To our lovely viewers out there, if you are with us live on Facebook, please like our page, and also if you have any question, please put them in the comment section. If you are here with us on Zoom, give us a wave and I would invite you to ask your question. Please also like our channel on YouTube at Teen Leadership and Entrepreneurial Development Foundation.com. Doc, to our final questions, what advice do you have for our viewers listening to us right now who are yet to decide about their future in the STEM?
Yeah, I will advise you should get into something that you love to do. Mostly people choose career paths based on the money that they might be making, but I think you also have to look at the impact that you will be making because we all need to make the world a better place. I feel like you should be passionate about what you want to do, and then you have to be focused.
Okay, so passion is really needed here if you want to get into a STEM career or any other career at all. Doc, some of us might want to contact you, to talk to you or even use you as our role models for the future. How do we get in touch with you?
You can find me on LinkedIn as Godwin Atta, Godwin Atta. Yeah, and I'm also on Facebook as I think Dr. Kofi. Yeah, so you can find me on LinkedIn, Godwin Atta.
Okay. Thank you very much, cherished listeners. Thank you, Dr. Godwin Kofi Adia, for such a wonderful section. I think for now we already understand who a structural and a civil engineer is, and we know what to do to get there. If you want to have a career in civil or structural engineering, you should be passionate about it, and you should also know that you have to work hard to get there, and nothing comes off easy, as he said earlier on. So we need to work hard as young ones if you want to get to where he has gotten now. We thank you all for today for joining us on this program. Until next time, we say bye-bye.
Thanks for having me.
Thank you, Doctor.
Bye.